pyramids, you have 10 lobes. All there is to it. Those are the internal structures for the gross. All right. And don't worry about that. That was just showing the collection system with the calyx and the pelvis out the ureters. IVP study. And then a little dissection with the removal of the inferior vena cava on the right-hand side. You now have the open kidney showing the vasculature all packed in there. But this is to show the renal arteries, right and left, coming off the abdominal aorta. There. And then you get a good look at the right adrenal gland, and the left is leaning right there. Okay, that's for endocrine system. And then down the back wall, there's the right ureter, left ureter. Just seen on the edge there. But this is really to get a good look at those renal arteries underneath the renal veins cut away. And then looking down into the pelvis, really straight down from above, the deepest point in here, bottom of the basin, P of D, Couchoke-Douglas. In the biz, P of D tells you that's the lowest point. And we just say, go back to the urinary bladder. Female, you've got the top of the uterus. Male, subtracted. From here to here. P of D. Lowest point in the pelvis. Okay, then we transition from the gross to the histo. And the first thing you'll note with the cortex is you get the corpuscles. Magnify a nice bunch of corpuscles. And that's just renal cortex overall. Corpuscles always tell you you're in the cortex column as well. So then we like to magnify on those. Your renal capsule layer is off to your right here. So now we're in the cortex. Renal corpuscle, or now Piggian corpuscle, which you know is combined glomerulus on the inside, a bunch of capillaries, and then the beginning of your uriniferous part, Bowman's capsule, a space into which filtrate will flow. There. And then where it goes in and out, where it's discontinuous for Bowman's capsule, just call it the VP. Vascular pole, vascular pore, little opening. And then the rest of it is tubules. All these parts of nephrons. All you need to tell is PT, DT, or CD. So when you're looking at these, well, here's a nice round one. Here's an oval one. PT, DT. We like comparing them. Down here, here's one, and here's one. Nice and round, more oval, technically thicker, thinner wall. PT, DT. And then completely different from those two are where the nuclei are touching. Yes, one against the other. Or over here. See how close the nuclei are. So that's a CD. Usually they're found in rays or clumps. CD, CD, PTs, DTs. Really give you a good, clear difference showing those three types of cross sections. And then for leg lecture, it's nice to know everything has capillaries. Understanding of the nephron is tubules plus vasculature, all tightly associated together. Okay, then we move to where there are no corpuscles. As soon as you don't see any corpuscles, now you're in medulla or pyramid. It's their absence that tells you you're down in the medulla or a pyramid. Same thing. And what you're seeing are largely collecting ducts, masses of collecting ducts. There are loops, little tiny ones, no ID. In lecture, you hear a lot about the juxtamedullary nephron loops that are amongst all these collecting ducts in the pyramids. And then once again, vasculature everywhere. Peritubular capillaries. Once again, just reinforce, I'll never ask you about them, it's just keeping them together, making a nephron. Alright, so corpuscles, cortex or column, no corpuscles, medulla or pyramid. That's how you keep it organized in the histology. And then you see an epithelial lining. So this is transitional epithelium, stacks of cells, particularly noting the ones that are bulging on the surface. So they're stacked volleyballs, big round cells stacked on top of each other. So once you make that determination, then it's easy. If the wall is thin, it's ureter. Very, very thick, urinary bladder. Or vesicle, if you wish. It's just seeing the transitional that tells you it's one or the other. And then the size difference, where ureter, you usually get the whole thing, whereas bladder, just part of it. Massive musculature in the wall. Always show you something like this where you get a nice magnified view with those bulging cells, the dome cells or pillow cells. Got to be transitional epithelium. All right. And then this is just the scanning look of the inside of the bladder with those dome cells or pillow cells. Transitional epithelium. And then never ever testable, once again, scanning. Nice look at renal cortex where you really see the depth. Bowman's capsule, glomerulus, the VP right in here. And then all these tubules. But with scanning, you don't get the detail to really tell the difference. So you just say, yeah, those are just tubules. Or a favorite is to put latex in the vasculature and then dissolve away the surrounding tissue. So what you're left with here is all the vasculature in the cortex of the kidney. A favorite, they often put it on the cover of black and white atlases. Looks like little brains. I said, well, those are glomeruli, clumps of capillaries. I like you to see it for lecture, where when you look around, you say, well, here's a good one right here where you've got the glomerulus, and then here's the blood coming into it, and here's the blood leaving. See the difference in the size? Afferent coming in, efferent going away. So you got a tremendous blood flow coming in and a trickle going out. Right at the VP. You see the same thing here. Afferent coming in, efferent going out. Well, where's the difference going? Let's say it's for lecture. All this fluid coming in, and then then a trickle leaving, you'd think this would get blown to pieces. But where's it all going? It's Bowman's capsule in the sewer. It's been removed, so you're not seeing it, but it just says, yeah, there's a lot of fluid moving from one compartment to another. My lecture, you should know by now, 48 gallons going from vasculature into Bowman's capsule every day. Big vessels coming in, tiny vessels going out, the fluid difference going into the uriniferous tubules. And then these are all the peritubular capillaries around everywhere else. Everything sheeted in capillaries. And then you're standing in Bowman's capsule at 1000x, looking out at the glomerulus. So here you're looking at the membrane.